Hi, in this Let's Create series, we're creating the classic Simon memory game where you have to remember the sequence of lit blocks. In the last episode, we added the light and sound logic. This episode will focus on the core game logic. Let's get started. When we start the game, we're dropped into the main menu with the lights on the board randomly flashing. We need to add a play button so we can start the game. So right-click, UI, button. In Unity 6, all these are Text Mesh Pro, so you'll be prompted to import the essentials if you haven't already. I'm just going to switch to the game view so I can see the UI canvas overlaid on the game. You can see that the button is tiny for me. If we click on the canvas, you can see that the UI scale mode is set to constant pixel size. Since I'm using a 4K display, this makes the 100 pixel button look very small. Instead, we can change this to scale with screen size. Then you will see you will get a reference resolution. It's probably best to build your game at the most common resolution it'll be used at. But for now, we can just leave it at the default. You can see my button has disappeared off. This is because the position has been adjusted when we changed the UI scale mode. If we set those back to 0, we can see the button back in the center of our screen. It's a much better size now. We don't want it in the center though, so let's anchor it to the bottom. Click on the anchoring widget and then hold Alt so we set the position and anchor it to the bottom. You'll see it puts it right on the bottom. We want it up a little bit, so we need to set the Y value to 30. We can rename our button Play Button for a bit of clarity. Then update the text to simply Play. That's good now. We just need to implement the logic to start the game. Then we can come back and add it to the on-click event of the button. So back in GameManager.cs, the first thing we want to do is add a reference to our play button. We'll want to hide it when we're playing and show it again when we finish. So under our game objects header, we'll add a new serialized private game object called play button. Whilst we're here in our variables, we'll also need two more for tracking the lights in the level we're on. The first is a private list of type int called level tiles. In here, we'll store the sequence of tiles we're trying to memorize. We'll also need a private int, which I've called current index, to hold the current tile that the user needs to press. This will obviously start at 0. All indexes are 0 up. Now let's jump to the bottom of GameManager.cs file and add the new play function. This is going to be a public function as we need to call it from our button, and we'll simply call it play. The first thing we're going to do is hide our play button now that we're playing. We use the play button object reference we've just added, and as it's a game object, we can use the setActive method passing in false to disable it. Then we want to stop the menu animation that's flashing the tiles so we can show the sequence to remember. For this, we can simply call stop coroutine and passing in the name of the coroutine we want to stop, which is menu tile animation. Okay. Now we want to create our level. I don't know how many tones you want to start with, but let's keep it easy and just add 3. We create a new list object for our level tiles using new, and we can set the initial elements in the curly brackets. We want random tiles, so we can simply call random.range between 0 and num tiles to pick a random tile, and do that 3 times. If you want to make this variable, such as if you had a difficulty setting, you could have a variable to store how many to add, and then add them in a for loop. I've just kept this very simple here. Now we're ready to play the sequence of lights for the user to remember. As this is going to be lights and delays, this is going to be another coroutine that we start with start coroutine, and we'll call it play sequence, which we'll create right now. The first thing we want to do is set the game mode to the listening state as we watch the lights flash. Then we'll add in a slight delay before starting the sequence. This is necessary as we want to make sure that the menu lights have stopped flashing and that there's been a long enough gap so that the user doesn't think they're part of the sequence. Then we are ready to iterate over the tiles and flash them. We use a for each loop that takes the integer index from the level tiles list. These are the random values we've just added in. We can then use this index value to call our playTone method, passing that index in, and also yield return the flash tile coroutine, again taking in our index. This means we'll have our sound and our tile lighting up. We use yield return before calling the coroutine as we want this coroutine to call it synchronously and wait for the result rather than starting it in the background. The flash tile will light the tile, wait, then turn it off. So we want to add a slight delay before we flash the next one, to add in another wait for seconds of our duration. Once all the lights in our sequence have been shown to the user, we're ready to play. Firstly, we set the current index to 0, as we want the user to press the first tile, and then set the game mode to playing. We haven't implemented any extra logic around the tile presses, but we'll use the game mode to drive all of this in a moment. But for now, that should be enough to check that the play button works. Back in Unity, on our Game Manager object, we need to drag in the reference to our play button. Then on our play button, we need to add the on-click event. Press the plus to add the action in, drag the Game Manager into the object slot, as that contains the function we want to call. Then for the function, choose Game Manager, Play. Then we can start the game to check this out. The menu is flashing, we press play and the button disappears, the menu stops flashing, and then our 3 random tones are played out. At this point, we can just press any tiles and it just plays them. So let's jump back into the GameManager.cs script and update that. So at the moment, our play light and tone function does just that, without any care for what the game is doing. We need to update this to fit in with the game logic. The first thing we need to do is ensure that we can only ever get the light and tone if we're in the playing game mode. So let's start by wrapping everything we do within an if statement to this effect. If game mode equals GameMode.playing. In this instance, we always want to flash the tile, so that's okay. But we only want to play the tone if we've hit the right tile. If not, we need to play something else and end the game. We know if this was the correct tile if the index we've clicked on is equal to the value stored in the leveled tiles list at our current position in the game, which is given by current index. Let's walk that through. When we start, current index is 0, so we need to click on the tile that matches the first element of our leveled tiles list. Excellent. So we play tone as before, then we want to increment the current index, so the next tile we click on has to be the next tone we played in the sequence. That would keep working, but we need to check when we get to the end. Once we've correctly done the last tile in the sequence, then current index will be equal to leveltiles.count. When that happens, we want to add a new light to our sequence. As before, we simply use the add method of leveltiles, and again use a random tile with random.range. That's added an extra light to our sequence, so it's time to play the sequence again for the user. So we start our play sequence coroutine. This will put us back into the listening game mode and play the sequence of lights before putting us back into the playing game mode so we can enter the sequence again. That's great. So the final bit in here is what happens when you click on the wrong tile. So in our else part of the loop, we'll first log out what level we got to using debug.log. Non-programmers like to start at level 1, so our initial level has 3 lights. We will output leveltiles.count -2. We set the game mode back to menu and re-enable the play button by passing setActive with a parameter of true. You could just leave it there, but it's a bit of an abrupt end to the game. What I think we should do is play an error tone, since this is an audio game as much as a visual one. So let's call a new method playErrorTone, and we'll create that right now. This is going to be very similar to playTone, but without the variable index changing the pitch. Instead, we'll hard-code the pitch to 0.5, then we'll play it immediately by getting the current time from the audio settings.dsp time, using play scheduled at the current time, then the set scheduled end time will be our current time, but rather than just playing for our standard duration, we should make this longer to make it obvious it's not correct. So add on 3 times duration here. That's it for the code. Let's jump back into Unity to test this out. We start with our flashing menu. Hit play, and after a short delay, we get our first 3 tones, which I can repeat, at which point we start again, but with 4 tones this time. I can get that correct too. Now this time at level 3 we've got 5 tones. Let's fail this one. great. You can see that the menu has reappeared with the play button, and we've got a long load tone to make it obvious we failed. In the console, we can also see it correctly states we got to level 3. Then we can hit play and start all over again. That's it for this Simon game. As ever, I've given you the core game logic, now hopefully you have the tools to expand it. If you're looking for an idea, I suggest introducing some buttons for difficulty, easy, medium and hard, with varying board sizes and also varying how many new lights are added each level. Then implement a high score text on the menu page, which updates when you get a new high score. And there's lots more you can do if you like. As ever, the full code is on GitHub and linked in the description below. See you next time.